Priyadarshini from the Department of ISC from NMIT. So in today's topic what we will discuss is we will discuss about normalization in DBMS. So basically why do we go for normalization? So before going to why do we go for normalization, let us understand what is normalization. So normalization, when we wanted a proper definition of normalization, it is the process of organizing data in databases to reduce redundancy. So what is this data redundancy all about? Data redundancy is like you have the same data. It is like the same data is being present at multiple places. So it is like you have the same data that is recorded in multiple tables or in multiple relations. It is, and moreover it is also that the same data is present inside the same table also. That might also be called as data redundancy. And what does it does? When you have lots of data redundancy, you have anomalies that will be present and that will also reduce the data integrity. So what is the basic goal of normalization is? The basic goal of normalization is to eliminate the redundant data. It is in order to make sure that we are going to remove the repeated data, and then whatever the dependencies are there. For example, in any relation, whatever the relation is, there will be functional dependencies that will be present. So with the help of normalization, what we will be achieving or what we will be understanding is to make sure that the data dependencies that has been present make some senses. So what is the relation between one attribute to the other attribute that is proper, and then to increase the efficiency and consistency of the relation that has been present. So basically we will be increasing the efficiency and consistency of the table that has been present. And next is like why normalize. So as I told, why will we be normalizing? What are the benefits of normalization is like it avoids data anomalies. So what are the different anomalies are like? You have insertion anomaly, updation anomaly and the deletion anomaly. So what is this insertion anomaly all about is when we are able to insert the data properly inside a relation, then that is not a problem. For example, if there are missing data that is being present, if there is a missing of one particular key where we wanted to enter the data, that is called as your insertion anomaly. And updation anomaly is like you have multiple tables, and in multiple tables also you have the same data, and in one table if you are updating, all the other relation is also to be updated. That will be called as your update anomaly. And deletion is like for the same is like we delete it from one of the relation and all the other relations still has the same data, then that is called as a deletion anomaly. For example, one particular student has left the college, only from the class, only from the college main database, main table the data has been removed, but in department table or in the class table the data is still present. That is called as a deletion anomaly. So once these anomalies are avoided, basically what we achieve is we achieve storage space and the data integrity will also be enhanced, and then the query performance. So when we wanted to retrieve the data, the retrieval will also be a little easier. That is the major benefit of using your normalization techniques. So next, as I told, we have discussed about the three different anomalies: insertion anomaly, updation anomaly and the deletion anomaly. Next is like what are the levels of normalization. So when we define that we are going to make our relation normalize, or when we are going to provide normalization, what are the different levels of normalizations that can be present? One is your 1NF, that is your first normal form. The second one is your second normal form, third normal form, boys code normal form, and the last one is your fourth and fifth normal form. So basically your fifth normal form is like it is not that commonly used. We are still with the help of 4NF only. And then what will be happening in your first normal form? The first normal form is basically for removing the redundant values in each of the attribute. So basically we will be concentrating on the concept whether there is only atomic value for each of the attribute that is being present. That we will be checking in 1NF. Second 2NF is like we will be checking about the partial dependencies. We will be checking about the partial dependencies. Third one is transitive dependency. Your BCNF, that is boys code normal form, is nothing but it is the stricter version of 3NF. And your 4NF and 5NF is like it deals with multivariate and joint dependencies. So now moving on to the first normal form, as I told, a relation is in 1NF if it contains only atomic values of like each of the attribute. Each cell has atomic values in it. So for example, what we can see is, so for example, it is like you have it, we have a table like this. In the table, if there are attributes, if these are the attributes, you have name, we have ID and we have phone number. So if name is like Anu, Arun, Akash, ID is 1, 2, 3, we cannot assure that everyone will be having a single phone number. So for example, they have two phone numbers. They have two phone numbers. this has one phone, Arun has one phone number and Akash also has one phone number, but whereas Anu has two phone numbers, which means that there is no atomic values that is being present over here. So this table is not in 1NF also. This table is not in 1NF also. So if our relation is what we have defined is not in 1NF, it means that the data or the relation that we have defined is not even a proper relation, not even a basic proper relation. That is what we can come to an end. So what this solution is like, we can make sure that we are going to decompose the table and make it in 1NF. So for example, this is how we will be able to do it. So for example, we will be making sure that Anu ID number is 1, the phone number, whatever is the phone number will be present. So now this is how we will be making sure that the table is in 1NF. So for example, if there are primary attributes, if this is primary attribute, what we will be doing is we will be decomposing this into a new table based on the primary key. If the ID is the primary key, based on the primary key, what we will be doing is we will be creating a new table. But for example, the attributes will be name and ID will be in one relation and the other relation will have ID and phone number. This is for your 1NF. So if you are going to 2NF, next is like if you are going to 2NF, if you are going to, this is an example of 1NF. So for example, so if you are going to 2NF, what will 2NF do is, in 2NF what we will be checking is, we will be checking about partial functional dependency. So what is this partial functional dependency all about? And so in partial functional dependency, if any subset of the candidate key, is present, and if that subset is able to identify any one of the other non-prime attribute, then that is called as your partial functional dependency. If our relation is having any partial functional dependency, then we can surely say that our table or our relation is not in 2NF also. So basically, what is the major thing is we have to check whether our relation is in 1NF initially, and then we will check for partial functional dependencies. So for example, so if this is the question that is being given to check whether your relation is in 2NF or not. So what is the relation is? Relation PQRST. These are the attributes that is being present and these are the functional dependencies that is being given. So initially we can check if it is in 1NF. So there are no data, there is no need of checking for atomic data. So it is in 1NF already. The second one is now we are going to check for the partial functional dependencies. How will we check? We have to check for the candidate key initially. Once the candidate key is checked, once we have got our candidate key, and then based on the subset of the candidate key, if there is any dependency, functional dependency, that is partial functional dependency, then we say it is not in 2NF also. So for example, so now we can see the candidate key for the previous one is PQS and the prime attribute. So basically from the candidate key, what we will be able to identify is we will be able to identify PQS as the candidate key, which means that is your prime attribute. Next one is like PQRST. So R and D are non-prime attribute. So here the subset, if we see P and Q are functionally, like R is functionally dependent on both P and Q, which is a separate subset of the key. So what we can do is what we are supposed to do is we are able to decompose the table again, and we are going to make sure that particular relation PQRST is decomposed into other relations. So how we are going to decompose is based on the functional dependency itself. PQ and R will be one of the relation, and then S and D will be one of the other relation. So this is how your 2NF will be working. Thank you.